Thanks for the introduction, Alexander. That's great of you. Thank you. That's a really tough act to follow. That was a very inspiring and thought-provoking keynote from Nicholas there. So I'm here, as you say, to talk about Neo4j 5. We went GA on the 24th of October. It was a really exciting release for us, not just for all the new features that we're delivering, but because this is the first time we've released our entire Neo4j product platform at the same time, all compatible. So that's everything from drivers, Bloom, browser, graph data science, the connectors, our whole product portfolio. So a fantastic achievement. So it's also obviously available in Aura and available through the AWS Cloud Marketplace with Azure and GCP coming soon. And just last week, we released the Helm charts for Neo4j 5's autonomous clusters. And I'll be talking about autonomous clusters later on. It's a really exciting new capability within our product. There's so much in Neo4j 5 that it wasn't really possible to fit it all in one session. So I'm focusing on the administration surface, the new capabilities that administrators can take advantage of. There's a companion session run by a colleague, John Stegeman. It's on tomorrow. He's focusing on more the developer data science experience, drivers, how to kind of query and get value from your graph using Cypher and the other improvements. There's some focus on indexing, so being able to kind of get to that start point in your query before you run your traversals quickly and effectively. And there's a session after, John, where they're actually going a deep dive into indexing. So there's a lot here. It's spread across 2 sessions. We've grouped the things that are relevant to Aura and Neo4j 5 because Aura now has the ability to create Neo4j 5 databases as well. So we've split that. So you'll see kind of the developer data science and language and graph model, kind of the ability to interact through Cypher. That's all kind of our experience pillar. John will also be covering, because there's a bit of overlap, some read and export performance. We'll be talking about some of the indexing. My session here today, we're going to focus on kind of the improvements we've brought in write and import performance, scale and availability, some of the cloud native operations that we've introduced, admin, operability and observability, making it far easier to operate and manage your databases, and then supportability and security. So let's kick off with the write and import performance improvements. So Neo4j 5, you've always been able to, with admin import, import a large amount of data really quickly to load up your graph. However, administrators often need to pull data in, maybe in nightly batch jobs from other database systems, maybe as part of an ETL process. And up till now, that hasn't really been possible. There's some great new capability in Neo4j 5. You can now perform an offline incremental import. So what this means is you can have your production database up and running, and at some nightly process, you need to import a large amount of data into the database. You can now bring that in as a CSV file. You'll need to take your database offline, run a preparatory phase. If you want, you can then bring the database back up. It has to be in read-only mode at this stage because we don't want any changes to the data before we've actually done the import. The build phase runs whilst the system can be online and read-only. It essentially creates like a delta of the database that is then merged in when the system's back offline. Now, the whole process can be run all in one in an offline mode, or you can phase it if you want to have the database available for read queries during the more lengthy build cycle. In terms of loading the data, it's 10 to 100 times faster than transactional loading, and is in terms of what you can expect in terms of incremental import speed, it will be comparable to the amount of time it took you to do your kind of initial data load at that kind of rate, because obviously it depends on your data model. Admin importer this time supports importing new nodes with properties, new relationships between existing or new nodes. There are indexes will be updated, uniqueness constraints are upheld, property existence constraints are upheld as well. You will at this time need to manually seed the cluster if you're importing in an offline phase. So now I'm going to pass on to kind of some of the indexing. This is more for what admins need to be aware of. So I mentioned John's session tomorrow and a focus session on indexing right after it. Will kind of take you through more kind of querying and using the indexes. But I wanted to kind of get across some important considerations if you're migrating from Neo4j 4.4 to 5. You need to be aware that Neo4j 5 no longer supports B-tree indexes. These were replaced in Neo4j 4.4. We introduced new range indexes, which provide support for comparator operators. So you can do equals, greater than, less than, etc. And they work across booleans, ints, floats, and strings, which also include searching with starts with, and temporal values as well. New point indexes were introduced. These are great for kind of geospatial kind of map type situations where you need to compute range and distance between points. Now, whilst they were introduced in Neo4j 4.4, you couldn't actually make use of them. They continued to use the B-tree indexes. But as a preparatory step before you move and migrate from 4.4 to Neo4j 5, you need to create these new range and point indexes because during the migration process, Neo4j will check that they exist, and once it's complete doing the migration, it will remove the old B-tree indexes for you. We also introduced support for indexing lists and arrays in full text indexes. So again, making it easier to find data within your database. And there have been some text performance improvements. We've introduced a new trigram analyzer that speeds up, that contains and ends with searches as well. Scalability and availability. I mean, this is kind of like, the real killer feature for Neo4j 5. It really lays the foundation for our future. You may have heard at Graph Connect, Emil talking about our vision for the future around knowledge lakes. This is like our foundation technologies. I cover both of them, but I think it's important to stress that actually composite databases are now part of autonomous clusters. This is our fabric, how you do ultra large, high scale with sharding and federation. And I'll talk a bit more about each of those in a minute. But first, I want to kind of go through autonomous clustering. It's perhaps one of the most sophisticated clustering architectures in database. It enables elasticity within your cluster. You can now scale out with more and more servers within your cluster. The key kind of innovation change within our clustering technology has been this you no longer need to run a copy of the database on every single server within the cluster. So previously, if you went from 3 servers to 5 servers, you increased your level of fault tolerance. You could obviously add more read replicas, dedicated servers for reads. But in Neo4j 5, what we allow a cluster to do is have as many servers as you want. Current scaling is up to 10s of machines. And each of those machines can host a read or a secondary copy or primary copies. You don't have every single copy of the database on every single server. So this kind of frees up and allows you to scale out. And I'm going to walk you through kind of an example in a minute. The other thing that is important to stress is obviously Fabric, or the Composite databases, is now an integral part of the cluster. So this means you have a shared view of the schema and security within the cluster. So let's say the administrator, you want to create 3 different fault-tolerant databases within your cluster, and you've got 5 servers available to do that. What's required? Well, you need only specify what you need, and the cluster figures out where to run it. So you'll say, I want to create database. I'm giving it the name knowledge. And my topology that I want to create within the cluster is I want 3 primary copies because I want some level of fault tolerance, and I want 1 additional secondary copy to provide read replica, read kind of query support. And I also want to use it to take my backups because I don't want to place a load on the primary databases. So, you just issue the command, autonomous clustering picks 4 appropriate servers within the cluster, and that's job done. You then want to move on and say, I now want to create the databases in yellow. I run a similar command. I just specify 3 primaries. In fact, if I've set a default value, the cluster can create 3 without me specifying the topology. Again, they get allocated to members of the cluster, and autonomous clustering will use its first algorithm that we've provided, which is an equal number. So it will distribute the databases in an equal number of databases per server. Then as you add your third and final database, it does the same thing. So you've got an even distribution of databases within the cluster. And future versions of minor versions of Neo4j 5 will introduce more placement rules and other ways of allocating databases within the cluster. Now, let's take the kind of scenario that one step forward. Let's say there's some seasonal demand. You want to increase the capacity. You want to distribute some of the databases across, some more servers. You can add in a new server. You enable it as part of the cluster, and then you just run a deallocation command to move some of the databases. Run reallocate to reallocate the databases across the cluster. If you want to then scale back in, you want to go from 6 servers back to 5, you deallocate the databases from the server of your choosing, and then you run drop and you remove that server from the cluster. Once you specified a server to be deallocated, if some other administrator went ahead and created some other databases, they wouldn't get allocated to that server because it's been flagged as deallocate. And all of this is done safely without affecting the fault tolerance level of the cluster. So this brings me on to Fabric. So previously in Neo4j 4.4 and prior versions, Fabric stood outside of the cluster. We had individual Fabric proxies. But with Neo4j 5, Fabric is now an integral part of the cluster. And for those of you who may be unfamiliar with Fabric, It's our way of enabling you to execute queries in parallel across many databases. You can chain those queries together to perform some really sophisticated real-time analysis. And there are kind of two kind of key use cases for Fabric. And the first, federation, where you're taking several databases, all with different schemas, and you're trying to aggregate the value of each of those databases and bring it up and solve and answer other questions within your business. The other is around kind of scale, enabling you to take a multi-terabyte database and shard it. So separate the data into individual databases that might be easier to manage than performing, backup and restores on, multi-terabyte data. Again, querying those shards is all done in parallel. So let's look at this in a little bit more detail. So in the case of you've got a cluster, you want to use it for sharding. Your application has customer accounts. How do you choose to shard it? Well, one way of sharding the application for accounts might be taking all the customer accounts that are A to G, or maybe it's a numerical identifier. You could do it in a range there, and then you've got H to M and N to Z. So this kind of gives you the opportunity. Each of these can kind of scale within their own databases. And you're able to access all that data by querying the Composite database accounts. Accounts holds a reference to each of those three shards. Another example is the federation. So if you think about how fraudsters sometimes look to take money from financial institutions, one of the ways is to submit a large number of applications across different business systems, because they're relying on the fact that they're all kind of individual isolated systems. You could create a federated fraud detection system by spotting rapid applications with varying information for personal information across those different database, loans, credit card systems. You can go beyond the cluster. So whilst I said, Fabric is part of the cluster, that doesn't stop you from being able to query databases or clusters that are remote from it. So this kind of really opens up the possibility of kind of querying archive data that you want to have in other clusters and kind of almost scale federated databases across clusters held by other parts of the organization. So just kind of quickly, I'm not going to go through this in a lot of detail. There's a dedicated session which I'll call out in a minute. But essentially, you're just creating a database, each of the shards. To create a composite database, you just say create composite database transactions. That's the name of the composite database. And then you create aliases which reside inside of the transaction database. When you then do show database on the transaction database, it tells you it's a composite database, and it gives you the constituent shards that exist within that configuration. This means that when you then query the composite database, you can then get back a list of those shards, which then allows you to query Fabric and iterate over the shards within the Fabric environment. So just to summarize, you can dynamically create sharded and federated graphs in Cypher. It's fully integrated into the database availability infrastructure. You get full fault tolerance, and you can go beyond the cluster. You can find out far more about Foundations for Scale with Hugo Firth and Tobias Johansson. They're going to go into some great scenarios and worked example of all of this. In keeping with kind of our work and partnership with the Aura team, there are some kind of changes that we do, but these don't just benefit Aura; they benefit our customers who provide Neo4j as a database platform within their organization. So they may be serving databases to business units within their organization. And for those of you who want to self-manage in the cloud as well, we've made some changes. So the first of these is the server-side routing, which was introduced in Neo4j 4x, is now enabled. It was previously disabled and you had to enable it. So this makes it far easier to just deploy Neo4j 5 behind load balancers in the cloud. And server-side routing, for those of you who aren't familiar, basically means that instead of the client having to maintain which server is the leader, the cluster will tell and route requests to the right server. And this is kind of pretty important when you consider that not every database will be running on every server within the cluster. So it makes it far easier for application developers and those using drivers to just send requests, let the cluster figure out where to route it. For those of you who need to lock down Neo4j 5, the admin role in particular, you want to give the admin role to some individuals. You don't necessarily want them being to go off and create databases. You can configure this in a security init file and restrict their actions. So you can deny them the ability to create a database using the immutable keyword. And the only way this can be overridden is if someone has access to the physical file system where Neo4j is running, and obviously network and other security permissions can be used within your organization to lock that down. I'm just going to go through some exciting improvements for the operations of our product. There's a whole talk about Neo4j Ops Manager. This was our new product release that came earlier this year. It's fantastic. It really opens up your capabilities to manage lots of servers and clusters. As an ops guy, you can manage multiple instances, you get your metrics and your status, help you with complex tasks, which are a bit easier to represent visually, like managing securities and cluster. And it provides some fantastic upgrade and migration wizards, which can kind of help you provide tailored steps and procedures to follow. You can find out more from Chris Shelmerdine, product manager for Neo4j Ops Manager, and some other great sessions as well. In terms of backup and restore, we've introduced far more capability with needing far less storage, up to 75% saving when it comes to using kind of the likes of full and differential backups. You can chain differential backups together and aggregate them and create a full backup if you want. You can do point and time restore within differential backups. So you can't do a point in time restore from a full backup. But once you've done a full backup, if you've got differentials, you can then go to any transaction or any point in time throughout that chain. There's an API to improve operability, and now the backup is done as an immutable file, so not a directory. So you don't have to worry about additional files getting copied in there accidentally or files going missing. It's a single file. Legacy backup available in Neo4j 4.4 is still available. You'll have to just modify one command just to inform it to use legacy mode, but your scripts and behavior will be the same. On the security front, we introduced impersonation. You could configure impersonation in the Cypher shell. You could use it in drivers. but what you weren't able to do was impersonate within the shell. So we've introduced the ability to start the shell impersonating a user, or once you're in the shell, to do :impersonate and then the username. This helps you test out the permissions that you've created. You can check scripts are executing correctly for users, and you can even then demonstrate effectiveness of your permissions policy to auditors or other sort of governance bodies. Supportability, there's some great changes. So we're excited to say that we're extending the migration window. So when you go from Neo4j 4.4 long-term support to Neo4j 5 long-term support, you'll now have 1 year to transition. So the nice overlap, and that will continue for Neo4j 6. Our old branching model we had with 4, where we had a patch release, so a minor release of 4.0, 4.1, 4.2, with each of those supported for 18 months. That's changed now. So in Neo4j 5, we have what's called a continuous release support model. This means that we'll release frequent features and fixes. That will happen all the way up to the long-term support release. And at that point, then we'll only release fixes. It does mean that it helps your move two-way migration from Aura to Neo4j or vice versa, because you need a version that will keep up with Aura as we release exciting new features and fixes. Self-managed customers will benefit as well. To facilitate this, we've vastly improved the upgrade experience that was previously available. You're no longer required to go from one minor version to the next. You can still go 5.1, 5.2, 5.3. But excitingly, you can now go from 5.1 to 5.5 or 5.5 to 5.10. You don't have to upgrade, but you will be upgraded if you need to take if you need bug fixes that come out in the later minor versions. Obviously, if you want to take advantage of new features, you can do the any-to-any upgrade as well. And this works with rolling upgrade within clusters. Migration, I'm not going to go through this kind of in detail. I mean, suffice to say, it's most important to prepare, review the migration guide, and get Ops Manager deployed as well. That can really help you in the preparation and planning and rollout. But basically, get 4 prepped by creating your indexes, check your configuration files, and 5 starts up. Then when you're ready, you can do Neo4j 4.4 online or offline backup. If you're going to do it online, make sure you set it to read-only. Perform your online backups, then restore, perform the migration. It's really important to stress, actually, that migration in Neo4j 5 does not depend on the size of the database. It's ultra quick when you compare it to migrating from 3.5 to 4.4. You don't need to make large changes through the database structure. It's just an update to the metadata, so it's very quick. Then once you've got Neo4j 5 started, seed your cluster, and then cut over your clients to the new server. There are some breaking changes in 5. We'll only introduce breaking changes in the major version, so there'll be no further breaking changes throughout the whole of 5x. The admin commands have been improved, and the arguments and settings are way more consistent now. This caused a lot of problems for new users to get their heads around how commands worked. So our experience in 5 is going to be a lot better for new users. It will be tricky for people who are existing customers and users to be familiar with the changes, but the restructuring and reorganization is a big improvement. I've talked about backup and restore. We've given better namespaces within the conf file. And also importantly, we help make sure that the database settings are applied appropriately to the database or the cluster. And Java 17 is now a requirement, up from Java 11 in 4x. So just to conclude and wrap up, and thanks so much for tuning in and watching. Neo4j 5 for administrators. We've delivered on write and import performance, read and export, scale availability, some cloud native operations, just general operational experience, bringing it in line with that great experience that you get in Bloom and browser, supportability and security. So thanks again and enjoy the rest of the show. Thank you.
Super cool. So thank you very much, Stu, for taking the time and for presenting. Technically, I think we have a minute or so we could answer one question live on stage, and then I know you will be moving down to the chat and help out with other questions. So do you want to take one question live?
Yeah, I'm happy to. Yeah.
Yeah, do we do one? So from Anthony on the index question, comes a question on indexing. I put it in here as well. Does create index build a range index by default in version 5? Are B-tree indexes converted? Will performance degrade if range or other is not re-added? I guess it's like a bundle of questions. But maybe we do
in one.
Yeah.
What I will say, so just if you're migrating from 4.4, you need to create your new index types in 4.4, and then that, as you migrate, will ensure that your B-tree indexes are then cleaned up. So they're not so much converted as say, they get populated when you start up in 5. Yes, so your performance will be impacted. If you used to have B-tree indexes and you don't create your new ones, yes, you would have problems in the migration process, but also without indexes, your performance would be impacted because you can't use them to find data in the starting point in your graph query. I don't know the answer to the first one, but I thoroughly recommend attending the focus session on indexing, which is tomorrow, I believe. I forget the time, but definitely attend that one.
Okay, that's all right. Cool. Thank you very much, Stuart. I think you will be in chat as we go now. Continue with the day. So there were a couple other questions. So Stuart will move over to the chat and answer a couple of these other questions. So don't do be patient. We'll try to help with these questions as we go. So yeah, thank you, Stu, for presenting, and see you
Pleasure.
soon.